will also be equal to mg, otherwise it will be minus the 2. So, it will be ma minus mg, whichever one is greater. Okay. So, you have the formulas here, you can have a look at them. Okay. Right. So, in this diagram again you can see the example of a table, and let us say a box on this table, and this box will experience two forces. One force will be downwards and one force will be upwards. The upwards force is Fn and the downwards force is Fg. And the formula again, if they are equal, it is at rest, you can say it is equal to mg, but if it is moving then it is equal to ma. Okay. Depends, you will have different kinds of examples and problems in which they are unequal and it does move, and then but if it's set to be at rest, then you will put them as equal. Okay. Now there is another force, okay, there is another force which is called friction. So what is friction? Up till now we have been studying motion, but we have been ignoring friction to keep the problems simple. But in reality, you know that whenever you are driving there is friction, whenever you are riding there is friction. Why do people fall when there is a rain? Because the friction changes. So, we need friction, it is not a bad thing actually, we need friction. When we are walking, the floor, if it is too polished and it offers less resistance, we tend to slip, right, and that is why we tend to wear shoes with soles that have some, that create some friction. So, friction is a resistance force. Okay. So, even you experience friction by the surface on which you are walking, you also experience friction by the air, you know, the air is also exerting a force on you, and if it is too windy you can actually experience it, but if it is not windy you tend to ignore it. So, that is why in most problems we normally ignore it to keep them simple, but sometimes if the friction has a considerable value, then we include it in the problem. So, this is a resistance force and it is represented by small f. Again, since it is a force, it is a vector. And another force that you must have come across is called tension. Tension is again a kind of a force, and it is represented by a vector capital T. Okay. So, do not confuse this with time period. This is a vector, time period is not a vector, right, although the symbol is also capital T. So, what is tension? Normally when you pull something, like you are pulling a rope or you are pulling a string, whether you pull it horizontally or vertically, if you hang something, you see that the string becomes very tight. You know, there is a very simple experiment that we do, the pendulum for example, you hang a bob from a string, so there is a tension in that as well. Okay. So, when the bob is at rest, it means that the tension in the string is equal to the gravitational force, right. So, it can be both in the horizontal direction and on the vertical direction depending on your problem. So, the example in your book right now, figure 5.8 shows a block on a surface, and you can see that this block is being pulled in one direction and the friction is in the opposite direction. And then there is an example of a block that is being pulled with a thread, and in this case this pulling force is called the tension T. If you are pulling something, you are creating a tension, right. Okay, can you please take a picture? Okay, thank you. Now, Newton's third law. When you upload these, please number the pictures, right, so that you know the order. You can upload it to WhatsApp. Okay. So we have Newton's third law. So what is Newton's third law? Everyone knows this, right? So in this case, action and reaction are vectors, they are forces. So if we have, for example, one force which is in one direction, then let us say this is FBC as in your book, then the opposite force will be equal and the direction will be opposite, and this is FCB. For example, if we call this B and if we call this C. So therefore, FBC is equal to FCB, and if we only look at the magnitude, then we can write it like this. But if we look at the directions, if we write them as vectors, then one will be the opposite of the second one. So this is equal to minus FCB. So this means equal magnitudes but opposite directions. Okay. Have you seen the homework that I have uploaded? Kar diya? Wow, that's great. So you know that since this is the first homework, it's like an open book. You can open your book, you can solve it and you can submit it. But before that, you should study all the concepts, all the formulas, practice the problems, and then you should go and solve this, okay? And keep a calculator and paper and a pencil with you when you are doing it, okay? Right, so okay, let's look at application of these concepts that we just studied, which are the Newton's laws, okay? And let's look at 5.1, okay? So this is page 93. Example 5.1. So let's look at the statement. We have three situations in which one or two forces act on a puck that moves over a frictionless ice along an x-axis in one-dimensional motion. The puck's mass is m is equal to 0.2 kg. Forces F1 and F2 are directed along the axis and have magnitudes. F1 is equal to 4 newtons, F2 is equal to 2 newtons. The force F3 is directed at an angle, which is theta is equal to 30 degrees, and it has a magnitude F3 is equal to 1 newton. In each situation, what is the acceleration of the puck? So what's the way to solve this? What's the first step? You read the problem and you understand the problem. Now he is talking about the figure on the right hand side, which is figure 5.3. You can see the diagrams. Now when you are dealing with the vectors and forces, it is always nice to draw a simple diagram, because it helps you imagine the problem, visualize it, and then you correctly apply the formulas. So even if it is not given to you, you can draw it roughly yourself, okay? It will help you. It is not a wastage of time, it is actually helping you. So in the first case, you see that there is a block, okay, that is being moved along the x-axis with a force which is represented by a vector F1, and the value of this vector is given to you, the mass is given to you. So you start writing what is given to you, the mass 0.2 kg. The vector